Morning. Good morning. Can you hear me?
Yes.
Okay, good. So we continue our lesson. Again, this is part 2 that I want to talk about the areas under the curves and between the curves. So if you remember from the previous session, there was a problem that is still left. I know about that. I will come back to and solve it. This is a national proof problem and it is also included in the book. I will come back to this problem later today, okay? But for having a warm-up, let me ask you to determine the area of this shaded region, okay? By the information given on the figure, I want you to find the area of this shaded figure, okay? Of this shaded region. I will pause the video and give you a little bit of time, not very much because I want to solve more problems today, and then I will come to you, okay? Thank you. Okay, so let me start solving it now. Sorry. So what we should do here, first of all, this is not area between the between the x-axis and one particular curve, yes? Because you see that the area that I want to calculate is one part of it is between this line and the x-axis, and the other part of it is between this curve and these two vertical lines and the x-axis. So I cannot solve this problem just by one integral. I have to divide this into two pieces and then I will try to solve the problem, yes? Okay, so how should we solve the problem? So I will do this. First of all, I need to know which number is this. So because I don't have any idea, you cannot guess. If the paper is not grid, it means that you need to calculate everything. So this I need to find. If I want to find this, I need to intersect these two curves, yes? Okay, so how should I do that? I need to solve a system of equations consisting of y equals to 3x and y equals to 12 over x. Okay, so if I want to solve this system, I start doing elimination. For example, I can equate the values of y's together, so 3x is equal to 12 over x. Then to solve this system, to solve this equation, I multiply both sides by x, so it becomes 3x squared is equal to 12. I divide both by 3, it becomes x squared equals to 4. And then I get two answers, plus or negative 2. Okay? But of course it is clear that I am in the first region. X minus 2 is not acceptable. The reason that there is a minus 2, because if you continue this line and if you draw the curve of this, there is another branch of that curve below. Okay, this is why you get two intersection points even though you don't see it here, because I didn't continue the curves because I didn't need them. But this is not a false or fake root here. But for our purposes, for this problem, it's not important. So we realize that x that I am looking for is x equals to 2, yes? So then it means that I can divide my area from here to here, and that is 2, and I can calculate area number 1 and area number 2 and add them together. For calculating area number 1, my function is this function. My function is this function. It starts from 0 to this line, and I am interested in the area below the curve. Of course, you don't need to find integral for this because that is a triangle, you can calculate it. But let us just everything doing integrals, okay, to practice more. So if I want to calculate area number 1, this becomes the integral from 0 to 2, my function 3x dx, and then plus the integral from 2 to 4, the function is 12 over x dx. Yes? Okay, now this is a simple exercise. So if I want to calculate these integrals, I need to find primitive functions. Primitive function for 3x is very simple, you know that. So it is 3 over 2x squared, and it goes from 0 to 2. Primitive function for 1 over x is ln of absolute value of x. But there is a 12 here because 12 over x can be viewed as 12 times 1 over x. So this becomes 12 ln of absolute value of x. Of course, here absolute value is not important because I am working in the positive values for x, but let us just keep it for entirety. So, and then it goes from 2 to 4. Then I have to put these numbers and subtract them, yes? So what happens? I have to put 2 in the x, and then I put 0 and subtract them. Of course, when I put 0, it is gone, so I don't need to be worried. I just put 2 here. 2 to power 2, 4 times 3 over 2 is 6. Yes, so this becomes 6. And then here I will have 12 ln of absolute value of 4 minus 12 ln of absolute value of 2. So let me just simplify this a bit. So this becomes 6 plus 12. I don't need absolute values at all. I can factor L. I can factor 12. Absolute value of 4 is 4. Absolute value of 2 is 2. So it becomes ln of 4 minus ln of 2. Of course, this is completely right, but I would prefer to write it even simpler. I just write 1 ln and I divide 4 by 2. Yes, so you remember we have a formula that ln of x minus ln of y is equal to ln of x divided by y. So this is the formula that you had in Math 3C. We also learned about this year. So the answer would be 6 plus 12 ln of 2 area units. Yes. So the answer to the problem would be 6 plus 12 ln of 2 area units. So you see, sometimes you have, because of the geometry of the area, of the region, you need to divide calculating the area into more than one step. Any questions here? Okay, let me sure that this is being recorded. Yes?
When you, like, it's not really related to this, but a primitive function is usually denoted by a capital letter.
Yes?
Saying, yeah. But what if you want to take the primitive function, you just put a figure in?
No, I don't know. You can invent something. There is nothing standard there.
So there's, okay, because I was searching around on it.
No, I don't say. Even capitals are not very. Even if you are talking about in that particular context, then people understand by capital F what you mean. Okay, but if you are talking about in a different context, you need to mention what you mean by capital F if you really mean a primitive function.
I guess it's not so common to do that. You just usually just put the integral sign.
Yeah, that's better. That's why. But you in the book, I don't know, for some reason this symbol without limits is not, so I just want to follow the book. But the people write that by this integral sign. And then, of course, if you have an integral sign of f of f dx and you want to do it once more, you can write it like this. Okay, so just let me see if this is working, this record.
Should I say A and not A1? Because you're calculating them together.
Yes, thank you very much. Yes, thank you very much. So I would, yeah. Let me just write this. That was my. I wanted to calculate them separately. Yeah, thank you. Okay, so this is one simple problem for warm up. Let us go to another problem. This is actually a copy paste of the book, but in the book you have the grid paper, and then you can read the information from the grid paper. Usually this is not the case. Okay, so you are given a picture or a region, and then you are supposed to find the area without having access to the grid paper to read the intersection points. Okay, so we want to see what is the area of this shaded region. And of course, this is completely symmetric. And then you see that this is y equals to 3x, 3 over x. This is similar to 12 over x in the previous problem. And you see there are two branches actually. One would be like that, and the other one would be like this. And of course, I have two straight lines, but I didn't continue them because I'm interested in this part. So, for example, assume that we want to solve this. This is a little bit more complicated problem. First of all, for example, you can employ symmetry and just calculate half of this area and just at the end multiply it by 2. For example, you can concentrate from here and calculate just this piece. Of course, you should have a good reason why this is indeed symmetric, but the picture actually is very nice, so you can say that this is symmetric. Otherwise, you need to calculate everything. You cannot rely on your instincts. But if you know a little bit about these functions, this is plus 2, this is minus 2, so they are exactly symmetric with respect to the origin. And if you know a little bit about the properties of these curves, they are always symmetric with respect to the origin as well. So take this symmetry for granted from my side and then try to solve the problem. So I would concentrate from here to here. And then when I calculated my area, I multiplied by 2. But even this problem is a little bit harder than the other problems that we have, yes? Because what is happening? Up to this point, you see, if I draw a vertical line, this area is between two straight lines, between these two curves, if I can call a straight line a curve, okay? And then after this vertical line, this area is between a curve and a line, yes? So again, I cannot solve this problem in one step. I have to understand that I have to divide it into two sub-regions, calculate the area of each region, and add them together. Okay? Because if you remember, we know how to solve the problem for this. If I have the area between two curves, I know what to do. I write the first function, assume that the top function is f, the bottom function is g. You need to calculate f of x minus g of x and integrate from a to b. But I cannot use this directly here because the problem is changing. In this area, in this region, the above curve is this one, the below curve is this one, and then suddenly after this vertical line, the above curve is this one and the below curve is this one. So that is the only thing that you need to pay attention to. Okay, so first of all, let me draw, if you understand what's going on, let me just draw this vertical line. Let me try to do my best. So this is, yeah, this is good. So this is the line that I will draw. So, and I divide my region, so let me call this one A1 and let me call this one A2. I want to calculate A1 and A2 separately and then add them together at the end. So for calculating A1, I know the boundaries. One of them is this line, one of them is that line, one of them is the y axis, and one of them is this axis, this line, which is still I don't know. So how should I find this number here? I know that this point is the point of intersection between this line and that curve. So I solve a system of equations and find the x-coordinate of this point. The x-coordinate of this point is exactly this number, hopefully understandable for everyone. So the first thing that we do, we just solve a system, y equals to 3 over x, and the other one is y equals to x plus 2. Okay, so let me make it bigger, it's easier for you to see. And then what should I do? I equate these two. I would say x plus 2 is equal to 3 over x, and then I multiply both sides by x. It becomes x squared plus 2x is equal to 3. I move this to the left, it becomes x squared plus 2x minus 3 is equal to 0. I hope that you can solve this. Okay, I can factorize it. So I need two numbers whose sum is positive 2. Here you don't have to factorize, you can use PQ or ABC formula. And then I want the sum to be positive 2, the product to be negative 3. So what are those numbers? Positive 3 and negative 1, yes? If I add them, it becomes positive 2. If I multiply them, negative 3. So from solving this equation, I get two answers. One of them is 1, the other one is minus 3. Okay, so you might say, what is minus 3? Of course, here in this picture, it's clear where is minus 3, because when I say the curve 3 over x, I told you that this includes two branches, and when I want to find the intersection point, you see that I have two intersection points. So this is telling me that one of them is 1, the other one is minus 3. Definitely this one is minus 3, this one is positive 1. Yes? Okay, so we realize that this point now is 1. Yes? So I would say that this is acceptable for us. Okay, now hopefully let me calculate this time separately these things. So A1 is equal to, I calculate the integral. Okay, can you tell me what are the limits for the area number 1 and what is the integrand that I have to write? Yes, what are the limits here?
0 to 1.
So 0 to 1 exactly, but can you tell me what is the integrand here?
X plus 1 minus 2.
X plus 2 minus x minus 2, exactly. But don't forget about putting pair of brackets around them. Yes? So is that understandable for everyone? Yeah. Yeah, so this is the upper function in this area. This is playing the role of the upper function, and this one is the lower one. So I write the upper one first and the lower one second. And then I calculate the integral. First I simplify. I multiply this negative sign in. So it is very simple actually. So because this x and that x are cancelled, I will get 4. So this becomes integral from 0 to 1 4 dx. And then what I have, this integral is simple. A primitive function for 4 is just 4x. And it goes from 0 to 1. So the answer would be 4. So this means that A1 is 4 area units. Yes? Okay, so I don't know if I have... Yes, I have some space here as well. So this is... A1, so I think it would be better if I take this picture that I have changed from here to there. Yeah, so okay, so now we want to calculate A2. But what is A2 now? A2 is integral again, but the limits are from 1 up to, by the way, this point. Okay, sorry, I have to calculate that point as well. So that is too early. So I need to go from here to here, between this and that. Yes? So I need to know what is this number. So what should I do? I need to intersect this curve and this line to find this intersection point. Okay, so I need to solve another system, a system including the equations. So 3 over x and y is equal to x minus 2. I equate them as before. So it is 3 over x. Of course, you might be able to guess by symmetry, yes? You can also use the symmetry here. So x squared minus 2x is equal to 3. And then x squared minus 2x minus 3 is equal to 0. Okay, I don't want to solve it. If you solve this equation, you get two answers. So one of them would be minus 1, and the other one would be positive 3. But of course, minus 1 is clear. Minus 1 is this one here. Okay, but this one is definitely 3. So that's my answer. Of course, it is clear if you use symmetry, because we realize that this is -3. By symmetry, this would be +3. If you just mention it, you don't need to calculate it. Anyway, so I want to calculate a2. I would say that a2 is the integral from 1 to 3. The upper function here, this is the upper function in this area, and this one is the lower function. So it becomes 3 over x minus x minus 2 dx. Okay, and then let me simplify this, so it becomes integral from 1 to 3, 3 over x minus x plus 2 dx. Okay, and then a primitive function, hopefully you know that, so let us just do it quickly. A primitive function for the first one is ln of absolute value of x. Here both 1 and 3 are positive, so I don't need to write absolute value. The primitive function for the other one is x squared over 2, and a primitive function for the other one is 2x. So I have to calculate this between 1 and 3, yes? So I put 3 everywhere. So it becomes 3 ln of 3 minus 9 over 2 plus 6. I simplify that. So it becomes 3 over 2, 3 ln of 3 plus 3 over 2. And then I put 1 here, so it becomes 3 ln of 1 minus a half plus 2. But if you remember, ln of 1 is 0, and 2 minus a half is 3 halves, yes? And now I write the number above minus the number below, so then you see that the answer would be ln of this one minus 3 over 2, but this one and that one are gone, so finally I get area 2 is 3 times ln of 3 area units. Okay, so the answer to the problem is this area plus this area that we found before, 4, and multiplied by 2, because we also have the same amount of area exactly here. So I add 4 to my answer here and multiply it by 2. So the answer, the total area, is equal to what? 4 plus 3 ln of 3, and then multiplied by 2 area units. So that would be the answer to this problem. Any questions? So you need to understand, it is not hard, but you need to understand what is going on. Sometimes, actually for harder problems, you have to break out, decompose the area that you are supposed to calculate into different regions and then add them up. Any questions here?
I have a question.
Yes, please.
If this would come on the test, what do you need to maybe prove that it's symmetric?
I would be specific in that. Yes, I would say that you can use the symmetry or whatever. In principle, yes, you have to show me that this is symmetric. Otherwise, I cannot do that. And of course, usually I cannot rely on my eyes. But I will make everything clear in the exam when it comes to an exam. Okay? Any other questions? Okay. So let us solve this problem, and I want to teach you a little bit around this problem as well. Okay. So determine the exact area of the region enclosed by this curve y equals to square root of 2x plus 3 and y equals to x. Okay, and then the x-axis, of course. So this is a nice problem from this perspective. It could, I don't know, they have considered this a level 2 problem in the book. I really don't consider it a level 2 problem in the book. From my perspective, this should be a level 3 problem or even sometimes higher. Okay, so if you want to solve this problem, you need to have a good visualization of the area. Okay, if you have calculator available, of course you can draw the graph of this function and see what's going on. But you really don't need that much. I don't know which part of the exam was it. Is it that part that you're not allowed to use calculator or not? But we can also check using GeoGebra. But here, so one thing that I want to know, I don't know if you have any idea about the function of a square root of x. So let us discuss this problem extensively. So if you want to draw the graph of y equals to a square root of x only, it shouldn't be in principle very hard for you, yes? Because first of all, you know that there is nothing here, because a square root of x is not defined when x is negative, so there shouldn't be any graph involved here. And then you know that, for example, if you put 0, it becomes 0, and if you put, for example, 1, it becomes 1, and if you want, you can give 4, it becomes 2, and then you have a rough estimate of the graph of that function. For the purpose of this problem, that's completely enough. So this would be the graph of a square root of x. But if you remember what is happening here, I am multiplying it by 2. So what will happen is that I will keep the shape more or less the same, but when I multiply it by a square root of 2, what happens? It means that I am multiplying it by square root of 2. So it means that I am multiplying my function by square root of 2. The form of the function will not change, of course. The height will change a little bit more. It should be multiplied by square root of 2. So the general properties of the graph will not change. And then hopefully you remember from our lesson in chapter 2, if I add something to x value, the effect of that would be a shift. And if it is positive, it should be a shift to the right. It shift to the left, and if it is negative, it would be a shift to the right. Okay, I am just talking about these things if you don't have any calculator available. If you have, or you have a graphical tool in your hand, you just simply draw the graph of that. Okay, so my point is that this graph would be very similar to this graph, but just by a little bit of shift to the left, because 3 is positive. So that is what I am saying. But you can immediately calculate these 2 points. You can do a little bit better. What is this point? The point here is where y is equal to 0. So here y is equal to 0. I can put y equal to 0 and find x. Here x is equal to 0. I put x equal to 0 and find y if necessary. Okay, so this hopefully give you an idea without graphical tool that what would be the graph of that function. Not exactly, but we don't know, we don't need exact graph. So let me put y equals to 0 first. Then what I get is that 2x plus 3 is equal to 0. It means that x is equal to minus 3 over 2. Okay, so I don't know if this is 1. So let us assume, let us make it a little bit bigger. 1, 2. So let's assume that this is minus 3 over 2. And then if I put x equal to 0, then I get y is equal to a square root of 3. Square root of 3 is a little bit smaller than 2, so let us assume that this one. So the graph of the function would be this. I'm not saying this is the best picture, but that is enough for our purpose, which is calculating the area. And hopefully every one of you knows about this graph. It's very simple. It's the bisector here. So this would be the graph of this, something like that, yes. And of course I don't need to go below. If of course this will continue, let me just continue, something like this. And then let us read the problem again. Determine the exact area of the region enclosed by this curve, this line, and the x-axis. So it means that this area is wanted. Okay, so hopefully you realize that you need to calculate this point. So you need to calculate this. Because if you see, this is the area that I want to calculate. It starts from minus 3 over 2 and it goes up to this point, which is not yet clear. I need to find that one. Okay, so be careful about all the details of this problem. So what I have to do, I need to set up a system again. Yes, I set up a system. Y equals to square root of 2x plus 3 and y equals to x to find those intersection points. So then what happens, it is 2x plus 3 is equal to x. Then I raise both sides to power 2. It becomes x squared. Be careful, you are solving a root equation. You might get a false root at the end. So then let me write x squared minus 2x minus 3. I move them to the right, equals to 0, and this is exactly the same problem. So let me just write, I need two numbers whose sum is minus 2 and the product is minus 3, so it is minus 3 and positive 1, yes? Equals to 0, I get two answers, x equals to 3 and x equals to minus 1. Here, this is really a false root, because you see that there are no two branches for this graph. This is the whole graph of the function, and if you see, if it goes down, there is no intersection between this graph anymore. There is only one intersection one. Why we are getting two answers? Because you know that when you are solving a root equation, this might be a false root, and indeed it is a false root, because if I put minus 1 here, the left hand side becomes 1, the right hand side becomes minus 1, they are not equal. So that would be a false root. So it is not acceptable, so this is the acceptable number that I have. So I realize that, okay, this one is 3. Okay, but the problem is much harder than you might imagine. Of course, writing the integral is not that hard. What is the integral? Can you tell me, can I solve this problem in one go, or I should decompose the integral in the area, the region, into two pieces?
It should be in two pieces.
Exactly, because this part of this area have nothing to do with this. It is between the x-axis and this curve. But the other part of the area is between this and that. So this part is the area between two curves. This area is between the curve and the x-axis. So I have to split it up. So let me just call this part A1 and let me call this part A2. But then you will see what the problem is actually. Okay, so if I want to calculate A1, I set up an integral. So this is the integral from minus 3 over 2 to where? To 0. Because I am just calculating between minus 3 over 2 and 0. And then I have square root of 2x plus 3 dx. Okay? And let me write A2. What is A2? A2 starts from 0, goes up to 3, and then I have the difference of this function which is above minus that function. Okay? But I hope that you now realize what is the problem. Can you realize what is the problem here? For example, concentrate here. It's still a little bit problematic, yes?
We don't have any method
Mm-hmm.
or any algorithm to find the primitive function for the square root of 2x plus 3.
Exactly. That is the problem, but this is something that you can overcome, and I will teach you how. If I just give you square root of x, you don't have any problems, yes? Square root of x can be written as x to power 1 over 2, and then you can solve the problem. Let me discuss about this. I discussed about this in a different color, okay? Let me ask you something. If I ask you, can you find a primitive function for x to the 2? Yes, you can immediately tell me it's x to the 3 divided by 3. If I ask you the same question for x plus 1 to the 3, what would be your answer? Sorry, x to the 2. What would be your answer? How do you calculate a primitive function for this? This you should, yes?
You expand it.
Expand it, exactly. But there is also an alternative way to do it. If you think a little bit wisely, you can somehow mimic this method to give an answer here. Can you now guess what is happening? If I want to solve this one, I just told you about the expansion because this method in general is not a Math 4 problem. But now I want to give you an alternative way to think about the problem without expanding. Can you just try to imitate somehow this method for this?
We can write it as x plus 1 to the power of 3 over 3.
Yes, it works. Thank you. Why? If I ask you now take the derivative of this, you use chain rule. Yes, you use the chain rule. How do you do that? You would say that 3 goes down, x plus 1 to power 2, but multiplied by the chain rule by the derivative of the denominator and then divided by 3. But because the derivative of this is 1, this is 1 and this one and this one are cancelled, and then you get the answer. So this is an alternative way from now on if you want to do it. Why this works? Because the derivative of this was 1. If I give you x squared, this will not work. Okay? But let me make it a little bit harder. So what is your guess now if you want to imitate again this? So 2x plus 1 to power 2. Can you guess something for this based on this new method?
X 2x plus 1 to the power of 3 over 3.
No, there is a difference here. Because here the derivative was 1. If I ask you what is the derivative of this one, the derivative is not 1, the derivative is 2. Yes? So let me just tell you what happens. Let me test your answer. You said 2x plus 1 to the 3 divided by 3. Okay? So if I ask you to take the derivative of this, how do you do that? You would write 2x plus 1 to power 2, but by the chain rule you have to multiply by this prime and then divide by 3. This 3 that cancel, that 3 that's okay. But the problem is with an extra 2 that you get, because the derivative of 2x plus 1 is 2, and if you don't care about this 2, what you get at the end is 2x plus 1 to power 2. So if I ask you what is a primitive function for this, and if you just naively answer this one, you will see that you will have a difference of factor of 2. But this is very good that you said this to me, because now I can divide everything by 2. I can divide everything by 2. On the right hand side I will have exactly what I want, but then you know that this 1 over 2 can go inside. So the answer to this problem is 2x plus 1 to the 3 not divided by 3 divided by 6. Is that understandable for this particular problem? Yes?
Yes.
Okay, good. So can you now cook up an algorithm? So you see, this doesn't play any roles. If it was just 3, I would do the same thing. I would write this to the power of 3 divided by 3, but because of that factor of 2 that is coming out because of the chain rule, I have to put a 1 over 2 to cancel that 2 coming from that. Okay? So you see that this number doesn't have any rule. I can change this number to whatever I want, but this number is important. This number appears, actually the reciprocal of that appears here. So now if I ask you, can you cook up a pattern algorithm for me? So if I ask you what is a primitive function for this expression, ax plus b to some power n. Yes, compare it with this. Compare it with this one, x to the n. For x to the n you know the answer. It's 1 over n plus 1, x to the n plus 1. But now can you cook up an algorithm for this one based on what I said and your previous knowledge by comparing it here? Let me write it in this way.
Divide by a.
So what should I, can you just tell everything to me? What should I write? Divide by a is correct. So it is 1 over a, and then? And then?
The same as before.
Yes, so it is x plus b to the power n plus 1 divided by n plus 1. Is that understandable now?
Yes.
Okay, so now we have this algorithm. So when we have this algorithm, so it was, I didn't talk about this because it's not in the book, but suddenly it appears in the national exam. So of course that is for Math D, probably Math D, I don't know, it is probably should be comparable to Math 4. Might be they have studied this before there at that time. Anyway, but now if I ask you, can you calculate a primitive function for a square root of 2x plus 3 for me, you would say yes, we can calculate that, yes. Because I can write this in this form, 2x plus 3. So now let me go back to the previous color. This is part of the problem. Okay, so let me just put them in a box for future. Okay, but now let me go back to the problem. So square root of 2x, my goal is to find a primitive function for square root of 2x plus 3, yes? Of course, the first thing that you have to do is as before. You have to write it as 2x plus 3 to power 1/2. Okay, now can you tell me what is the answer? According to the rule that we just got here, it's 1 over a, which is 1 over 2. And then I have 2x plus 3. Let us just do it in my head. I have to add 1 unit to this. It becomes 3/2. And divide it by 3/2. Dividing by 3/2, okay, let me just write it. So divide it by 3/2. And then what happens? This becomes 2 over 3, and this 2 will cancel that 2, so I will get it 1/3. So it becomes 1/3 of 2x plus 3 to power of 3 over 2. So that is my primitive function. Is that understandable? And if you don't believe in that, you need to convince yourself by differentiating it using the chain rule. 3 over 2 goes down. I have 1/3. 3 over 2 goes down. You get 2x plus 3 to power 1. 3 over 2 minus 1 is 1 over 2. But you have to multiply by the derivative of the base, which is 2. This 2 cancel that 2. This 3 cancel that 3. And then this one is exactly your square root function. So what we have done is completely correct. Okay, so remember this. I will take it to the other page, and that's a little bit unfortunate. So okay, so I need to take these two integrals with me. So if I can do that quickly, hopefully. No, this is not good. So let me be more careful. So I have these two integrals to take with me. Okay, let me make them smaller to save some space. So that these are the integrals that I have to calculate. And we also learned that the primitive function, let me just write it, the primitive function for square root of 2x plus 3 is equal to, what was that? 1/3 of this function. So 1/3 2x plus 3 to power 3 over 2. So is that understandable? Okay, now we have these two, we have to calculate these integrals. So that's actually, this was the hard part of this problem, but now you can solve the problem easily. So what happens? Area number 1 becomes, the primitive function is this, from this number to that number. Okay, so let us put 0. If I put 0, it becomes 1/3, 3 to power 3 over 2. If I put minus 3 over 2 here, this becomes 0. So the lower one is just 0. And then here, this becomes square root of 3. So the answer is square root of 3. So A1 is the square root of 3 area units. And now I want to calculate A2. A2 consists of two parts. The first part, the primitive function is the same, but of course the limits are different. So don't think that you don't need to calculate. You have to calculate it again because the limits are from 0 to 3 this time. So it becomes 1/3, 2x plus 3 to power 3 over 2, and then minus the primitive function for the next one is very simple, x squared over 2 from 0 to 3. So I put 3 here, so it becomes this, If I put 3 here, it becomes 9, 9 to power 3 over 2, and then I have 9 over 2. Now I put 0. When I put 0, this is cancelled. When I put 0, it becomes 3 to power 3 over 2. Okay? And let me simplify this. This one is square root of 3. How should I calculate this? 9 to power 3 over 2 is 3 to power 2 to power 3 over 2. So it becomes 3 to power 3. 27 divided by 3 is 9 minus 9 over 2. If I simplify that, it becomes 9 over 2. So the total area is the sum of these two numbers, 9 over 2 plus the square root of 3 area units. Okay? Is that understandable? Yes? By the way, let us try to do it with GeoGebra to see how this will go. So I would write integral. By the way, I realized what was the mistake. This command doesn't calculate the area. It calculates the integral of the first function minus the second function. This, if you remember, I was thinking why my answer is not the same as GeoGebra, because I realized that this function doesn't give you the area, it gives you the integral, which sometimes can be negative. So GeoGebra cannot take care which one is above, which one is below. You have to take care of it yourself. But here I would write a square root of t, and then this is 2x plus 3, and then the other function is x, and then we realized from where to where, from minus 3 over 2 by calculation up to 3. Yes, so that would be the area that we are interested in. If I punch it here. Okay, so the area that they got is this number. Here there is no problem because this function is always above this function. For the functions that sometimes this function is above, sometimes the other function is above, you need to be careful. I thought that GeoGebra is capable of considering that by this function, but it is not. This is why my answer was correct, but GeoGebra in that way was producing a different answer. So the answer that we got from Wolfram Alpha was the correct one, which was matching to my answer. So this is this number. I don't know if this number that I got is exactly this one or not. So let me punch that one here. 9 over 2 plus square root of 3. 3. Yeah, it's different. I don't know this. Okay. The reason is that you see GeoGebra. I don't know how to eliminate this. This part is also included in this one. Okay, so you know it is not possible. Pardon?
When you define the integral, did you put there's an argument for setting?
No. I realize my mistake is this. I haven't done any mistakes. The reason that GeoGebra is calculating, this GeoGebra doesn't understand that we want to calculate from x-axis above. So it is calculating this triangle as well. We can subtract the area of this triangle, of course. What is the area of this triangle is not hard to calculate. The area of this triangle is how much? Is 3 over 2 times 3 over 2. It's 9 over 4. So I have to subtract this value from 9 over 4, which gives me a 9 over 4. So what I have to punch in, so I need to subtract 1 over 4 from what GeoGebra is calculating. But GeoGebra is calculating a smaller number, isn't it? Let me double check again. Did you see any flaws? Let me also go back so that you can also see if there is any flaws in my calculations. So from minus 3 over 2, 0, 0 to 3. So was it 3? Yes. And then what we are doing, I put 0 here and 3 here. Yeah, everything is okay. So 0, 3, 0 if I put here, it's 3 to power 1 over 2, and then it becomes so 3 to power 3 over 2 divided by 3, so it becomes this one, and it is 1 over 2, so that's right. If I put 0, if I put this one, it becomes 0. So what I have done here for area 1 is completely correct. For area number 2, this one is correct. That's exactly the same thing. And this one is also correct. Now I put 3 here. This is 6, 9. 1/3, 9 to power 3 over 2, minus 9 over 2. But if I calculate 9 to power 3 over 2, it is 3 to power 2 to power 3 over 2. So it is 3 to power 3, it's 27. But I have a division by 3, it is 9. And then I have minus 9 over 2 at the end. Yes. So 9 minus 9 over 2 is definitely 9 over 2. And then I put a 0 here. If I put 0 here, this is gone. This is 3 to power 3 over 2 divided by this one. Again, this is this one. Okay, nobody told me that I have done this mistake. Okay, now I got it. I was careless. So this, I go back to horizontal. It is not finished yet. It is 9 over 2 minus a square root of 3. Yes? So let me, so that is good that we checked it with GeoGebra. So what I calculate, I forgot to subtract this. What, pardon?
I thought it might be that it's still not right.
No, I actually made a mistake, because at the end I have to go back to horizontal line and subtract these two numbers. So it is 9 over 2. So let me just write it in this way. So this means that area number 2, it's good that we calculated using GeoGebra. So okay, but of course I need to fix that one as well. So this is area number 2. And okay, let me now clean everything here. This is not the total area. The total area is the sum of these two numbers. Total area is equal to the square root of 3 plus 9 over 2 minus the square root of 3. So it is 9 over 2 area units. Okay, I can check the book. Let me just do it immediately. It is on blue pages on page chapter 4, problem number 24. Pardon?
Maybe it becomes the same thing if you subtract triangles.
Yes, yeah, that becomes the same thing, but I want to make sure that the book 24, I have the correct answer. Yeah, it is written 4.5 area units, so that's correct. Now that is correct. And the reason that you see this discrepancy in GeoGebra, because GeoGebra is calculating the area between these two curves from minus 3 over 2 up to 3. So it is also including this triangle. This is not something wrong, because the instruction that I have given out GeoGebra is to calculate everything between these two. But the one that I want, I have to subtract this area of this triangle to get that one. So this is something that I want to know. Okay, but the reason that I am very interested in this problem is there is a trick to solve this problem much simpler. Okay, and I want you to teach that trick. Okay. Any questions so far? So we were able to calculate it finally, and that was my unfortunate mistake that I forgot to subtract it. Okay, but now there is a very nice trick. I want to teach you about that. Let us go back to the diagram. In this diagram, let me put my eyes here. So I am looking from below. Okay, but let us see what happens if I look from the right hand side. Okay, when I look from below, what is happening? I have to decompose my area into two parts, because one part of the area is between these two and the other part of the area is between these two. But look, if I look from this perspective, what is happening? The area that I am interested in is always between the same two curves. I don't need to decompose it into two parts, because the lower curve in this case is this, and the upper curve in this case is that. And this helps you to solve this problem much simpler, even from primitive function points of view. So this is the reason that I brought this up, and I want to talk about this extensively so you learn this trick. Okay, so how should I solve this problem using this trick? I would say let me just try to copy paste this picture with me and take it to the other page. Okay, oops, it takes everything now. Okay, so let me just do it quickly here. So what I'm saying is this. I don't need to extensively draw everything. So here we have this, and then we have that, and then I am interested in this area. Okay, so let me write. What is this function? This function is given in the problem to be this. What is this function is this. Okay. Now, if you remember what was that point, so what is this point? Do you remember? This point was 3. So let me take that one away. So this point was 3. If I ask you what is this point, you can also answer to me. What is this point? Can you say?
Also 3.
It's also 3, yes, because it lies on this line, and this line y is equal to x. When x is equal to 3, y is also equal to 3. Now, if I want to look from this perspective, then the lower bound is this axis, the upper bound is this axis, and the area is enclosed between this curve and that curve. But you need to switch your perspective from x variable to y variable. But this is very simple, yes? For this function, y equals to x, it seems exactly x equal to y. So there is no difference here. But for this function, y equals to square root of 2x plus 3, I can raise it to power 2. It becomes 2x plus 3. And let me calculate x from here. So it becomes 2x equals to y squared minus 3. I divide by 2. X becomes 1 over 2 y squared minus 3 over 2. So from x perspective, from actually looking at it from the left-hand side, I have these two functions. And there is nothing, you remember, this x and y are just conventions, yes? It doesn't matter how I look at the problem. So let me look from left this time. And now can you just write an integral for me? I want to test your understanding. So can you just help me to write the integral from this perspective? I just help you to write something here. Instead of dx, I should have dy. Okay, can you tell me what are the lower bounds if I want to look here in this way? What is the lower bound for this area from y perspective?
0.
0. And what is the upper bound?
3.
3, thank you. And what is the rightmost function? The rightmost function is this function. How should I write it? I should write it as y, not x, minus the function which is to the left. What should I write it? I should write it this function. So it becomes minus a half y squared minus 3 over 2. Okay. Might be the book is considering this way, but even understanding this is level 3 problem, not level 2 problem. Now you see I can solve this very simply by interchanging the perspective from x to y. Okay? Is this understandable for everyone? So I have changed the perspective from x to y, so the function instead of dx I have dy, but what I want to write are no longer functions of x, I want to write functions of y. But when I was considering x, I was writing the top function first and the bottom function later and subtract them. But now here my perspective has changed. This is the x positive. So if you think this is going upward, then this is higher than this one. So I would write this one first minus this one. Yes? So now let me calculate this. You see it is very simple. A primitive function for y, when y is the variable, is like x, so it becomes y squared divided by 2. I have a negative sign here. A primitive function for y squared is y third divided by 3, and there is a 1/2 and a negative sign, so it becomes minus y to the 3 divided by 6. and the other one minus minus is positive, the primitive function for positive 3 over 2 is just 3 over 2. Don't say x because your variable is y in this case. And what you have to do is to calculate it from 0 to 3. And the good point is that you don't need to care about 0 because everything will vanish. So what I need to put 3 here. So it becomes 9 over, let me just put it. It becomes 9 over 2 minus 27 over 6 plus 9 over 2. Okay, let me simplify. 9 over 2 plus 9 over 2 is 2. 27 over 6, let me simplify by 3. It becomes 9 over 2. And 9 minus 9 over 2, it's nice, yes? Do you agree with me? This is just one line solving the problem. But I will consider it as hard problem not because the solution is simple, because coming up to the idea of solving the problem in this way might be hard if you haven't have this enough experience. So from my perspective, this problem is definitely a level 3 problem, no matter how you want to solve the problem. Is there any questions here? Is that understandable? So this idea of changing your perspective from x-axis to y-axis sometimes could be very and extremely useful. Okay, any questions here? Good. And if you want, because there is only 5 minutes left, I designed another problem for you of this type. You can have a screenshot on it, or of course I will upload the video. I will recommend you to try to solve this problem from both perspectives again. From x perspective, it would be a little bit lengthy, and from y perspective. I really strongly recommend you to solve the problem. But in these 5 minutes, I will solve the last problem for today. It's a little bit of different in nature, yes? But that's very simple. It's a combination of 2 problems. And on Friday, I will finalize this chapter, and hopefully you have received my email that which pages you don't need to do for this coming exam. I send a message to everyone on a SchoolSoft. Okay, so determine the exact area of the region enclosed by this curve, the x-axis, the y-axis, and the tangent line to y equals to x at x equal to 1. Okay, so you need to do some job to find, some work to find, not job, some work to find the area. So first you need to find the tangent line, because the area that you are interested in is the area enclosed by the curve, the y-axis, and the tangent line to the curve. Okay, so if I want to sketch something for you, I will have, for example, this. You don't need to be very, very precise. As long as you understand what's going on, that's enough. So hopefully you remember something about this exponential function. This is something like this. And now here, for example, point 1, we get some number here, a point here, this is 1, and I draw the tangent line. Okay, so this is the tangent line here. But now, which area I am interested in? I am interested in the area between the curve, the y-axis, and the tangent line. So it means that I am interested into this narrow area. Is that understandable? I want to calculate this area. So what should I do? This area is the area between two functions. One this function, the other one is this function. This function is definitely just given to me. This is up to me to find myself. And this is mentioned, it is the tangent line. So first I need to combine my knowledge from the tangent lines. So what should I do? I differentiate the function. This is a simple function to differentiate. It is e to power x. And then you find the k value. So the k value is e to power 1. I replaced x with the x coordinate of the point of tangency, so k becomes e, and then if I want to write an equation for the tangent line, it is y equals to the k value plus the m value. But how should I find the m value? If this x is 1, the y value is e to power 1 because it is lying on this graph, and this should also satisfy my equation. So it means that instead of y I put e, instead of x I put Oh, so that's a very bad picture of mine, okay? The tangent should pass through the origin, so that's a very terrible picture. But you see, even though this picture is totally wrong, it will not affect my solution, so I really don't need to spend time on it, okay? But anyway, it must better probably to find the tangent line first. So you see that the y-intercept is actually equal to 0. Now I realize that my picture is actually awful. So the tangent line equation is this. Okay, so of course I should be able to anticipate this, because that is this function e to power x, its derivative is equal to itself. So of course I told you that this is terrible, but I don't need to, because it would be troublesome if I want to clean this. So it's not that. So the tangent should, the reason is that this is the wrong exact picture, but this should go from here. So you need to find that area. Anyway, but it doesn't play any role. So if I want to solve that, I need to integrate between these two limits from 0 to 1, the difference between these two functions, as simple as that. So the area would be equal to integral from 0 to 1. The top function is e to the power of x, the lower function is e times x, and then you need to calculate this area. But if you remember, a primitive function for e to the x is e to the x itself. A primitive function for minus ex, e is a constant, so it becomes e times x squared divided by 2, and it goes from 0 to 1. If I put, so let me just do with 2 times, so it becomes e to power 1 minus e over 2, so it becomes e over 2. And I put 0, it becomes e over 0, e to the 0, which is 1, and then I subtract them. So the area is equal to e over 2 minus 1 area units. Okay, so is that understandable? Good. So this is actually the whole lesson. This finding the areas is very important, especially if you want to study in technical universities in the future. But I really recommend you to try to solve this problem. You see that this national exam problem the question was not actually very easy at all, even if you want to solve it in any way. Okay, so I recommend you to solve this one, and I will end this. Thank you for listening.